Okay, in this concept we're going to talk about geometric probability. And the types of problems where this concept is valid have to do with things like, for example, if you have a shape, right? So if you have, a square, or if you have a circle with a square inscribed in front of it, right? And part of the shape is shaded and the other part is not. And then you're being asked to determine the probability that, for example, if you throw an object, a dart or an arrow or whatever, then what is the probability that that object being thrown will land in one region or the other, right? The shaded region or the non-shaded region, right? So the probability of an object landing in a shaded region is the area of the shaded region divided by the area of the entire region. So in this case, it would be the area of this shaded part of the circle, right, divided by the area of the entire circle, which is all of this, right? So let's look at an example of how we would determine these areas to get the probability. What is the probability that a dart lands in the shaded region, in this shape, right? Which is a square with an inscribed circle inside of it, right? So the circle has radius 2 feet. Each side of the square is 4 feet, right? So again, the probability is area of the shaded region divided by area of total region. But in this case, the area of the shaded region can actually be acquired by taking the total area of the square and then subtracting the area of the circle, right? To get whatever is out here, right? That's the area, that's how you get the area of the shaded region. So it's the area of the square minus the area of the circle gives you the area of the shaded region. Once you've found that, then the total area is simply the square of each side of any side of the square, right? So 4 feet squared is 16 feet, or 4 feet times 4 feet is 16 feet squared. So area of the square, again, 16 feet squared, which is side squared. Area of the circle is pi r squared, so pi times r, which is 2 feet, right here, squared. So the area of the circle is 12.6 feet squared, right? And then once we subtract these two, subtract the area of the square, subtract the area of the circle from the area of the square, so the area of the shaded region is this much, and then we divide this area of shaded region, by the total area, which is the area of the entire figure, which is the square. So 3.4 feet squared divided by 16 feet squared, or square feet, gives us this probability. So remember, probability is a decimal or a percentage. Okay, so when expressed as a decimal, it's just a decimal, so 0.2125. But it can also be converted to a percentage, right, by multiplying by 100 and then adding the percent sign, right? So that gives us 21.25%. Okay, just like we have down here. So keep that in mind. It can either be expressed as a percentage or as a decimal. Both ways are fine. And here we have our exercises. Please pause the video, work on these, and come back for the solutions. Okay. A point in the figure below is selected at random. Find the probability that the point lies in the shaded region. So this is clearly a parallelogram, right? And so the entire area of the parallelogram is simply the base times the height, right, as we know. And for the triangle, the area of the triangle is half times base times height. So let's find some of these areas. So the area of the parallelogram is 3 times 2, which is 6 units squared. Okay. The area of the triangle is equal to 1/2 times 1 times 2, which is 1 unit squared. Okay. So essentially all we need is to divide the area of the triangle by the area of the entire figure, which is the parallelogram. So the probability is the area of the triangle divided by the area of the parallelogram, which is equal to 1 over 6, so 1 unit squared divided by 6 units squared, which is 1/6. Okay? And do keep in mind, probability can also be expressed as a fraction, which is perfectly fine, because a fraction can be converted to a decimal, right? So this is equal to 0.166, etc., 7, which is equal to 16.67%. Okay? Last exercise, we have a triangle inscribed inside the square shown below, of side 7 inches. Find the probability of a dart landing in the shaded area. So since this is a square, this is also 7 inches, and essentially the height of the triangle from the vertex to the base is also 7 inches, right? Because it's the same as this side or this side, right? Which are both 7 inches, right? So in this case, we need to find some areas. So the area of the square is equal to 7 inches times 7 inches, which is 49 square inches. Okay. The area of the triangle is equal to 1/2 times base, which is 7, times height, which is 7, which is equal to 1/2 of 49, which is 24.5 square units. Okay, so the area of the shaded region is 49 minus 24.5, which is equal to essentially 24.5, right? Square units. So the probability is equal to area of the shaded region divided by area of the square, which is 24.5 square units over 49, or I'm sorry, this should be, it should be square inches, right? Because we have the units, they are inches. So these should be inches, okay? 24.5 square inches divided by 49 square inches, which is 0.5, which is also 50%. Okay. All right, and this is it for this concept. See you in the next video.